And with that, I will hand things over to Tanya. Thank you.
Thanks, Dan. Hi, everyone. Again, I am Tanya Izett. I'm a board member with Hudson Taconic Lands. Welcome and thanks for spending part of your evening with us. We will begin with our land acknowledgement. It is with gratitude and humility that we acknowledge that we are learning, speaking, and gathering on the ancestral homelands of the Mohican people, who are the indigenous people of this land. Despite tremendous hardship in being forced from here, today their community resides in Wisconsin and is known as the Stockbridge-Muncie community. We pay honor and respect to their ancestors, past and present, as we commit to building a more inclusive and equitable space for all. So, I'd like to now introduce Tom Carroll. Tom is tonight's speaker. He is the Conservation Committee Chair for the local Homewaters chapter of Trout Unlimited. Tom is a retired environmental health professional. He has a background in life science and the physical sciences, and he is an avid fly fisherman who lives along the Wynants Kill in Averill Park. Tom has great affection for water conservation and native fish, and he will be telling us about stream restoration along the Poesten Kill. Over to you, Tom.
Thanks, Tanya. Thanks, everyone. Thanks for coming. So a couple things about tonight. You know, a lot of the pictures that you see are all going to be from Rensselaer County, and many of them are from the Hudson Taconic, lands properties. We have a lot of good, beautiful streams and good trout water in the county. And so there certainly is easy enough to find examples of what I'm looking for to show you. I also am hoping that when you, as you go through this talk with us tonight, that you'll look at streams a little differently when you're done. I'm hoping to, bring in a little bit of, a little bit of science behind what goes on in the stream. So a little bit about Trout Unlimited. I'm going to go through this pretty quick because this is not the fun stuff. But Trout Unlimited is a nationwide organization, and our mission is to protect, meaning streams that are in need of protection, streams that are already in good habitat, good cold water, fish habitat. They need protection. Reconnect, and that's really two things. To reconnect streams that are bisected by man-made fish barriers, and also to reconnect streams to their historical floodplain. And I'll tell you more about what I mean by that as we go. Restore, we'll talk about that also, taking streams that have been, let's just say, mismanaged or poorly managed, or befell some miserable fate, that we'll try to restore those. And sustain is to keep our work going through changes in climate and forward in history. So Trout Unlimited is it's a nationwide volunteer and professional organization. There are paid staff in Trout Unlimited. I'm on the volunteer side. There's 42 councils, 400 chapters, a lot of members. Tonight, when I mentioned to you a lot, really what I'm referring to is our regional office. They have an office in Sharon, Connecticut, where they have staff that provide us an enormous amount of hands-on technical assistance to do this stuff. They have geomorphologists and engineers and quite a bit of expertise in doing this work. And so they support the chapters, and you couldn't do it without them. TU also does all our not-for-profit support. So we are really under their wing, so to speak. It's a wonderful benefit to us that we don't have to do all the various tax filings. Trout Unlimited does it for us. And of course, they do advocacy on a national scale. There's also a New York State level to Trout Unlimited, 24 chapters, much of the same kind of work. But I do want to point out here that a lot of the funding comes from the regional office and the state level. So they raise money for the purpose of helping chapters fund work like this. And it's expensive work. It takes quite a bit of money and quite a bit of expertise to do it. So Rensselaer County, our Homewaters chapter, really includes all of Rensselaer County, a little bit of Washington County, and a little bit of Columbia County. So it's a pretty big area. We have about 180 members. One of the projects that we have is called Trout in the Classroom. We have 6 schools, high schools, that they actually raise fish eggs, brown trout eggs, from an egg to a fish in a refrigerated aquarium in their classroom to learn about the fish life cycle. It's an interesting program. We do red surveys, which are reds are fish nests, for lack of a better term. It's a location in the stream where fish breed, and particularly for brook trout, we like to find those and map out where those where those spawning areas are for fish, so that we can protect them. Part of our mission. Riparian planting. The riparian zone is basically the banks of the stream, and we'll talk a lot about why riparian plants and trees are important for stream management. Macroinvertebrate surveys. There's a lot of insect life in the stream, and that's, when we say macroinvertebrate, it's not strictly bugs, but it's mostly bugs. And you can tell a lot about the water quality in the stream by which species of bugs live there. So we'll go out and we'll look at these invertebrates, figure out what they are, and that will tell us whether the water stays cold, whether the water is oxygenated. It gives you a lot of information about the stream. We'll talk about the stream restoration. We've also have recently 6 high school fishing clubs. So I like to say we're not just a fishing club. Try to limit it really as a conservation organization. But I will say that we do like to fish, and so we like to bring people along fishing with us. So it's a great organization. So tonight I'm going to talk about 2 places: a site behind the Poesten Kill Fire Company, the firehouse in Poesten Kill, where we did some extensive work, and what we call the Wagner Pool. It's a junction pool where the Quacken Kill and the Poesten Kill meet. It's also not far from the village of Poesten Kill. I do want to make everyone aware that we have wonderful collaborations with folks in the county. The Rensselaer County Soil and Water Conservation District is remarkable for us, because it's a great symbiotic relationship, so to speak, because we can provide them expertise they don't have. Like I say, hydrogeologists, engineering folks that are specifically trained in stream management, and they can provide us resources that we don't have, like seeding machines and people power. The Rensselaer County Conservation Alliance is another source of people power for us. They're a group of sportsmen's clubs, fish and game clubs, essentially, that are also very interested in conservation. Not to mention the Hudson Taconic Lands. I have a couple of wonderful links with the Hudson Taconic Lands. Later on, when you hear me talk about trees that we installed, trees that we buried in the stream to help control erosion, those trees came from your Valentino family forest parking lot. When you guys made a parking lot, we got the trees and we used them for stream work. It's excellent. Not only that, Hudson Taconic Lands conserves so much land, and with that land comes a whole lot of stream miles. It's invaluable to have that property available to the public, available for people to fish, and simply conserved. One of our projects, the fire company site, was originally brought to our attention because in the days of the Rensselaer Plateau Alliance, you guys paid for a flood study along the Poesten Kill, and our site was prominently mentioned as a place that was contributing a tremendous amount of sediment to the stream, and causing it was not just causing, it was part of a flooding problem that was damaging the environment and needed some work. So we were able to work together with our Soil and Water, with TU, with NYSDEC, New York State Department of Environmental Conservation, to come up with funding, come up with a design, and get some of this done. So we can't do this stuff without the collaborations. I think that's in your motto: community and conservation. Another thing we do is temperature monitoring. This is prior to doing stream management or stream restorations. We run equipment. We run in-stream thermographs to understand the temperatures in the stream, and really to identify the places that need the work. I mentioned the red surveys. I'm going to talk a little bit later on too about egg stocking. People are probably familiar with fish stocking, where adult fish are released into the stream for people to fish for. Egg stocking is a little different in that we put in, freshly laid fish eggs and raise them in the stream instead of in a hatchery. So you get what's more like a wild fish. It's a little bit fussier to do, but it's something that we're trying out to see if we can, get that learning curve and can we do this? Of course, we're not fish and we don't know how to do this properly, but we're trying to figure it out. There actually is some equipment that we use called Whitlock boxes that are designed for doing this. So I'll talk more about that in a bit. We've done quite a bit of riparian replanting along the Hoosick River, which was that site. It's a canoe launch. It was once the Rensselaer Land Trust property. Now it's Hudson Taconic Lands. Dill Brook, formerly of the Plateau Alliance. We did a sizable replanting there in 2 locations, and we've done quite a bit of replanting along the Poesten Kill for our projects. I talked about the macroinvertebrate surveys. Along the Wynants Kill, we're doing something called sea slap sampling, and actually I'm having a mind block on what sea slap actually stands for, but it's basically we're doing nutrient sampling and various other water chemistry sampling along in an impoundment in the city of Troy, the Burden Pond. It's part of a DEC's environmental justice program to see if what can be done about that pond, which used to be quite a community resource, but is really silted in. It's completely filled with sediment, and it's turned into a marsh. And there's some effort to see what can be done about that. It's actually an impoundment of the Wynants Kill, and it's not too far downstream from the Stolson Preserve, which is another one of your properties. Stream access, we could do a whole night on talking about stream access and how that changes. Let's just say most of the streams in the county are privately owned, and to get access to those streams is sometimes impossible and sometimes quite possible. Depends on the property owners. So we've been working with DEC and the RCCA to open up as much access to the streams as we can for people to enjoy them. Some future projects we're working on towards a dam removal on the Quack and Kill. This is a spot called the Quack and Kill Reservoir. This is not the Martin Dunham Dam. This is a different reservoir. It's farther down. It's smaller, but it's part of the same. It's still an obsolete water supply dam. Built at the same time as the Martin Dunham Dam. It's about 20 feet tall. Again, filled with sediment, obsolete, and the owner of the dam wants to eliminate it. So we're trying to see if we can help them raise the money and get that done. And something else we're going to try out is our program we call Stream Stewards, very much like what you guys do, where you have a person that keeps an eye on one of your properties. We have a lot of very popular fishing areas, and we're going to see if we can organize a series of stream stewards to have some eyes on some of these places and see if we can do cleanups, look for problems, invasive species, etc. as we go. Okay, so no more writing. We're going to get all into pictures here. This is one of the land trust properties. This is the Bone property along the Quack and Kill. If you look at this particular stream, it's kind of zen. It's really a nice picture here in a nice spot. But like I said, I'm hoping to give you guys some terminology about stream dynamics so that you can take with you the next time you see a stream. You'll understand why the stream is so zen. It's it's complicated, but it's not that complicated. So if you think about it, a stream is really quite a large amount of energy moving through a forest. It's kinetic energy. The water's moving. The steeper the ground, the faster it goes. The faster it goes, the more sediment it can carry. So if you have a stream that's moving really fast, it's going to move a lot of material with it. The dilemma is the stream slows down and then it drops off that material someplace. So when you see a stream like this that's kind of in a zen condition, really what you're seeing is the stream is in a state of equilibrium, where the amount of sediment coming downstream is roughly equivalent to the amount of stream that's going downstream. So the stream it's moving material, but it's not leaving it all in one place or taking it all from one place. It's kind of sharing it pretty nicely with the forest. So a couple things to look at here. So, and we'll talk about these later. You'll notice that on this side of the stream over here, that the bank is lower. So that's what we would call, and I have better examples later, that's what you'd call a floodplain. When this water level comes up, the water goes into the forest, and hopefully it doesn't damage the forest. It might leave some material, it might leave some sticks and branches and leaves and move all that around, but it doesn't tear much out. It doesn't uproot trees, it doesn't move rocks around. The forest is pretty stable, and that's Zen, that's that equilibrium. You'll notice on this side over here that there's kind of a line here. That is what we call bank full. That's about the highest the water gets before it enters the floodplain on the other side. So this up here would be your riparian zone. So this is the forest on the banks. This is actually part of the stream bed. And then you have the stream. Now this particular stream doesn't have much gravel in it. It's in a lot of places, it's all the way down to bedrock. So it has a rock bottom that's, and so there's not a whole lot of sediment to move around. It's part of the Zen maybe. Another thing to note are these fallen trees. These can move around in a flood, but these are also important sources of habitat and actually important sources of carbon for the stream. And that carbon feeds the invertebrates, which feeds the fish, which feeds the birds, which feeds the raccoons. So this is the bottom layer of the food chain is all this vegetation that you see. Also want to point out all the rocks. So these are glacial leftovers. These rocks, there's quite a few of them, and it's a steep stream. So all these rocks are scattered around the stream bed. And you can learn the history of how those rocks got there. You can look at them and say, what happened here? So here's a different stream. This is the Kinderhook Creek, also in Rensselaer County, but you'll note it's different. First of all, it's flatter, so the water's moving slower. It's a bigger stream. The bottom doesn't have a lot of rocks, just these big glacial erratics and a few here and there. Where are the rocks? Well, you see all the gravel? That's all the gravel that came down the hill. The gravel was mobilized by the energy of the stream, and it came down here and it filled it in. You'll see over here what's called bank full. That's as high as the stream can get before it floods out into what looks like a hayfield back there. And the riparian zone is in between. That riparian zone is protecting that hayfield from being torn out or filled with gravel, or maybe left alone. You don't know what's going to happen in a flood. It could do any of those things. So this is more of a valley bottom stream as opposed to a steeper stream up on the Taconics. And it's nice fishing. All right, this is the Poesten Kill. It's another property, another Hudson Taconic Lands property. This is just below the falls in Barberville. A couple things to point out here, just what we've already talked about. You can see the floodplain, and in this floodplain, unlike the other ones, it's really well connected. In other words, the water doesn't have to go up very high before it's into the forest. But you'll see that the forest is pretty intact. It's not torn apart. Another Zen stream here. It's in equilibrium, and these trees are sort of the stability, while the water is sort of the energy. It's the kinetics. So the stream is at this point nice and calm, and going through the forest, but it's moving energy through the forest, which is stabilizing the banks of the stream. You'll also notice on this one that there's a series of what we call step pools. The water, it falls, it goes slow, it picks up speed, it falls, it goes slow, it picks up speed. These step pools are a sign that excuse me, that the stream has shed its energy. So it's not moving a lot of material, because when it slows down, it drops all its material, and then it doesn't have time to pick up new stuff. This is a very stable situation in the stream. If you were to add in a tropical storm and add a bunch of water to this, that would change. The stream could move these rocks. It could rip up the trees. It could tear up the forest, depending on how much water you see. So you might ask, how does a stream move a rock like that? Well, if you put enough water behind it, it might just physically move it through sheer force. Now these rocks are here because they're probably big enough to withstand whatever forces this stream generally generates. But the smaller rocks can move. But these big rocks can move too, because the stream can remove the gravel underneath them that's holding them up, and they'll start to roll. So in a big flood, you can't count on these rocks staying where they are. So a lot of times damage from flood isn't just from water, it's from trees and boulders moving around. Ice can move them, ice can break the rocks. So this stream is really, it's erosion in action. There's constant movement of a material in this stream. Excuse me, whether it happens slowly or fast, it's always moving. Move to the next. So here's a little better example of how much power a stream can have. If you take a look at how did all these rocks get here? Well, the stream put them there. How did that tree get there? The stream put it there. This is bedrock. This is bedrock. This is the deep pool. You know, at one point in history, or maybe it was a couple of times, there was a big enough storm that it moved all these rocks down the stream and left them here. And if you think about it a little bit here, this is basically just a bigger version of that step pool that you saw before. So in a big flood, the water would be pouring through this, and it's just a step pool. And typically, if you're in the forest, like you saw before, at the smaller version of this, you'll see them fairly regularly. The energy is dissipated, then it picks up more energy and it dissipates. So the streams don't have brains; they don't think of this. But by losing energy this way, the stream slowly but surely stabilizes itself over time. You know, if you were to try to create something like this with a bulldozer, you'd spend a lot of money and spend a lot of time trying to move this kind of material into positions like this. Stream is extremely powerful. This is why they were used for water power. They're excellent, excellent sources of power, kinetic energy. All right, let's talk about trees. These are sycamores. They're a species of tree that are really adapted into the riparian zone, and you can see how well their roots are holding the soil down. But when those trees first grew, those trees were buried. The roots grew in soil, and some of the soil is lost. So this is a floodplain. The trees are keeping the soil in place. Actually, these are all baby sycamore trees waiting for a tree to fall down. But if one of these trees falls down, suddenly at the next flood, this soil is available to move down the stream from that kinetic energy of the stream. So, like I say, the forest is stability, and the stream is the kinetic energy that just moves everything that it can. All right, so here's a nice place to sit and look. You can see here the floodplain and the flow of the water. This is all pretty nice. This is also another plateau property. Hudson Taconic Lands property. This is the Ingalls Preserve, but it's a really good example of the stability of the forest and the dynamics of the stream. If this stream were to flood, I doubt there'd be any measurable damage in the forest. What you'd lose is the man-made stuff. The bridge and the bench might take a beating. So it's another good example of a stream that's in equilibrium and a good place to sit on that bench and feel your zen. Same stream, the Black Brook, but this is a barrier to fish passage, they call it, or aquatic organism passage. So this dam, as I understand it, was an ornamental pond. It's very old. The dam is obsolete and probably failing. But dams like this are problematic for stream health because they warm the stream. They create a different environment above the dam where it's warmer. You have different species of fish, different species of bugs. It creates a completely different environment. But the thing that's most noticeable about them is this is a barrier to passage. The fish below can't get to the fish above. So it separates their gene pool into two separate populations, and over time, that could be a problem. It very well might separate fish from their food supply or from their spawning grounds, the areas that are ripe for spawning for fish. So the population upstream or downstream or both could perish because they're separated from their sort of historic area to spawn. It doesn't do the population any good to be split in half like this. So these kinds of things are things that we at Trout Unlimited like to see if we can, get these put back in a normal situation. Now, you got to be careful when removing dams and things because you don't want to create a flood problem that didn't exist before. So you wouldn't just take this out. You'd replace this with some feature that would modify the flow and manage that sediment transport and the flow, so you don't have things, excuse me, bad things happening out along the way. Like for instance, this is somebody's driveway and it's a small bridge they put in to get over the stream. Certainly you don't want to take out a dam and tear out their bridge. So it's tricky stuff. Let's look at some more barriers to passage. This is a natural barrier. This is a stream in a state park in Rensselaer County. But this, you would see, it's a natural barrier, but it's kind of a partial barrier. There's a big pool here where brook trout gather because it's not easy to get past this. But I've actually watched brook trout almost get up this stream and almost get up there. So, and try repeatedly. So chances are when the flow is right, the fish can get past something like that. They may not be brainiacs, but they are certainly determined. And so, things like this are really natural breaks in the population, but not complete breaks in the population. Another step pool there, you can see the pool, the drop, the pool, the drop. It's a very stable piece of stream. Here's a familiar spot, the Barberville Falls. Probably a total barrier to fish, except one species of fish I can think of. And no, we don't have salmon in the Poesten Kill. Think about the American eel. American eels are pretty resourceful and are known to be able to get over even pretty complicated fish barriers like this one. Because it's sloped enough and there's enough ledging, they can get up there and move on up the stream. And yes, eels are fish. Here's one that even an eel can't get by. This is called a perched culvert. This is a little bit of a puzzle that fish can't seem to figure out, because the water, there's no easy way for a fish or an eel to get up that little stretch and get going. Yeah, you might get a jumper or two, but then he's got to make it through the pipe, and the flow in that pipe is pretty quick. This culvert is probably also undersized. And you can see that, because usually undersized culvert like this, you'll see a huge pool below it, because when this stream is flooding, the soil here acts like a dam, and this acts like a fire hose, and the water comes out of there at such a velocity that it starts transporting the sediment. It tears up the ground, it tears out the bottom, and it moves all the material downstream to clogging up other stuff. If you go back to, before we were at the Ingalls Preserve, right at the top of the Ingalls Preserve, you'll see, if you go there when it's not so cold, you'll see an example of a perched culvert. All right, let's talk about the projects we did in the last couple of years. This particular one is called the Wagner Pool, which is right here. This is the Poesten Kill, and this is the Poesten Kill. They flow down towards Wagner Pool here, and then the Poesten Kill continues on to the Hudson. You'll see it's quite agricultural. And these kinds of agricultural lands are very vulnerable to flooding. But the quizzical part here is the reason that this is such good farm soil is because of the streams. This material was brought in by water a long time ago. So these agricultural lands owe their existence to the stream, and they have to cohabitate. This is the place I said where, this spot is, we picked this because, first of all, it's a popular fishing spot. Right here, there's a parking area for fishermen, and all this stream bank is public fishing rights. It's deeded public fishing rights. The property owner has given over the rights to the state of New York so people can fish there. The problem is it's also a pretty good swimming hole, and we get a lot of other users besides fishermen that use the property. And technically, it's not for fishing. It's not for swimming. It's the access is for fishing only. So we get a lot of users that put a lot of wear and tear on this particular site. Let's talk about the project a little more. This is what the plan was, and this is what we did. This is the Poesten Kill, Poesten Kill, Poesten Kill. So here's the big pool I was talking about. There's a smaller one here, and a lot of erosion here, a lot of erosion here. And like I said, there's a lot of overuse by people who, they walk all over everything, they camp all over everything, and believe it or not, they even steal the rocks out of the stream and take them home. There's a lot of garbage, a lot of wear and tear on this site. So the plan is, the swimmers have continually rearranged these rocks for some reason. I can only just say beer mussels. They move the rocks around to raise the depth of the pool, to do different things. and I'm not exactly sure their end goal, but they do it, and it creates huge amounts of erosion here. So the plan for us was to build what they call a J hook here out of rocks, bigger rocks than people with beer muscles can move, and control the flow and save this pool. In a J hook, this is underwater. It's a couple of feet underwater, and there's more rock under that. And this end, both ends are up above, up into the bank full area. So these walls are sloped down to the bottom of the stream and then slope back up. This is a tree we went to put in. These are, like I say, the trees that came from the Hudson-Taconic lands. We used at this site. So here's a look at the site. You can see some of the erosion from the foot traffic. You can see some serious erosion down here, erosion over here. The swimming hole you can't quite see from this camera angle, but I want to point out this tree right here, one that we called the magic maple, and you'll see why in a second. You can see, again, a lot of foot traffic, a lot of erosion. The rocks that they moved around are all in here. Here's the magic maple. And there's another look at that maple tree. It's a silver maple tree, and it's completely undermined. There's virtually nothing under it, and none of us could quite figure out why it hadn't fallen over. Losing a tree like that is going to just accelerate the erosion in the pool. So it's one of the things we wanted to save, that, and we wanted to narrow the stream, deepen the stream, and put in some what they call grade control to control the level of the pool, so that it wouldn't in a big flood lose continue to lose material. A better look at the magic maple, and this is after the project. So the material is dredged from the stream and put under there. This is the high side of the J hook. It actually, down here, it gets even higher, and it tapers down till it goes underwater. Well, this is a look at the magic maple about 8 months later, when they had a flood that topped the magic maple, topped the bankful mark, and flooded the cornfields. This picture is just sort of evidence that all the work we did didn't wash away in an enormous flood. Anyway, so here's the J hook as it goes down underwater and it comes around. This is a tree. This tree is 20 feet long, buried in the bank. There's another tree here, 20 feet long, buried in the bank, covered in rocks. Let me show you some more. Better look at the J hook as it comes around. Water above these rocks is about 2 feet deep, and all these rocks, if you were to look up, there's 3 to 4 feet of rock under what's visible. So there's 85 tons of rock there. And there's another tree we put on the other side, again, a 20-foot tree buried into the bank, going up to bank full. And so far it's lasted pretty well. Right now, if you go there and look, a lot of material graded in. In other words, instead of losing material, it's capturing material now. The banks look better, and the magic maple hasn't fallen over. Just for perspective, this is the Poesten Kill coming in, and the Poesten Kill's over on this side. And those rocks are not randomly scattered. They're put in, they're surveyed in. They're measured and placed precisely to maintain a grade at a certain height, so that we can, like I say, maintain the flow in the pool. Okay, let's talk about the next one. About 2,000 feet upstream is the Poesten Kill firehouse. This site was chosen, like I say, because of a flood study that the Plateau Alliance did. The stream was severely eroded in Tropical Storms Lee and Irene, and then unfortunately, someone thought, well-intentioned people thought it would be a good idea to get in there with a bulldozer and dredge it out and pile all the material on both sides of the stream. Sounds like a good idea, except the problem is that you turn the stream into something more like that culvert, where the water is forced into a narrow space, a deep and narrow space, so the water gains a lot of velocity, and it just becomes like a fire hose, and it tore out all the material they piled up on the banks, all went back in the stream, and now the stream was eroding at an incredible rate. They were losing 3 feet a year every time it rained. They would lose more. It was quite a problem. Let me show you some more pictures. Oh, here's the plan. This property owner on the other side didn't want to participate, so we couldn't use the same J hook method. We used what they call rock veins. 280 tons of rock in this project. and 7 trees. Well, there's more trees here than we actually had, so the diagram isn't exactly right. But there's 1, 2, 3 veins were added and 7 trees were buried. An interesting thing about this that I didn't talk about is this is called a flood channel. So it's dry most of the time, but when the water gets high, there's a separate channel opens up, and that actually used to be the stream 20 years ago. So the stream has moved over substantially in the last 20 years. So these rock veins underwater, they disappear into the bottom of the stream here, and they come up, in this case, to bank full, which in this case is about 6 feet high. So they're much bigger structures than in the other pool. So let's take a look. Here you can see the eroded banks. Oh, and these 2 sycamore trees here are enormous. The 2 of them, we estimate they're 150 to 200 years old. It would take two or more to get your arms around them. They were spectacular specimens, and it was part of the project was these trees must not be disturbed. But you can see the eroding bank here, here, and here. This is at a pretty good flow, so the stream is up a little bit higher on this. This was this summer, so this water is very low. The normal level would cover up most of those rocks that you see. There's that big sycamore, and here's the eroding bank. This is before the project. Looking upstream from the same spot, scale is a little hard here, but depends on where you measure. That bank is 4 to 6 feet tall. Just for perspective, keep an eye on this White House for the next picture so you can see, not completely after, this was in progress, but the 2 upper veins were completed. That's after. So the idea here is that when the water comes down, it will go up. It can't go, as the water goes up this vein, it falls back in the stream. So it deflects the water out. And because of that, you'll dig a pool in front of the vein. But this hollow here will gather material. So instead of losing material to the stream will deposit material there. So you go from a state of erosion to a state of what they call aggradation. And at some point, in a couple of years, the stream will reach some equilibrium, and the material wouldn't move very much. So this is also another good example of what we call natural channel design. We don't like to use artificial materials. You could use what they call gabions, which are big wire cages filled with rocks. You can use Jersey barriers. You can use all these things that'll work, but this is nicer. So and this is an engineered solution. So the heights of the veins are precisely measured to within some tolerances. They have a 2% slope. The trees, like I say, here's the total one here, about 20 feet long into the bank, or everything is precisely measured to height so that we know when the flows come in that the rocks won't move, and the stream will come to a certain height at certain flows, so that you can manage the erosion. Here's partially completed vein number 2. You can see the flags where it's all marked out, and there's the vein number 1 is up there. Some of these rocks are the bulldozer couldn't pick them up. They're so big he had to slide them in. There's one of the plateau's trees buried in there. We try to make it look as nice as we can, and the tree provides stability for the rocks. It provides stability back into the bank. It also, as time goes on, the flow will dig under that tree and make habitat for fish. That's us burying a tree with a big rock on it so it won't float up. The goal is to get the trees down below the water table so they stay very wet. That way they won't rot. They'll be there for a very long time if they can stay wet. Here's you can really see how much erosion was there. One thing I forgot to show you here. I'm going to go back. Sorry if I'm making you dizzy here. Just how much erosion there was. 2.8 feet a year, 6,000 cubic feet per year. That's about 300 tons of material a year going downstream. And the bank moved over about 20 feet since 2007. So sorry, I don't cover your eyes if you get dizzy by me going fast. Okay, that's our projects. This is one of the monitors we used ahead of the project to get some data on the water quality ahead of time. This one's called the Mayfly. It's about it's a land-based unit. It's solar powered. It also connects to the web, so it transmits its data in real time every 5 minutes. It collected data on water depth, water temperature, and specific conductivity. So it could tell us how much material was dissolved in the water, like road salts and things like that. I'd like to say it's still functioning, but a beaver chewed the wire and the ants got into the motherboard because it was warm in the winter. So we're looking for ways to replace that. It's a nice tool. But it took a beating because it was outside for a couple of years. This is this is a nice juxtaposition of modern technology and low tech. This is another type of thermograph. It doesn't transmit to the internet, but it is Bluetooth capable, so it transmits to your phone when you get close to it and take it out of the water. And we use just a common ordinary brick to keep it in place with some rebar to nail it into the bottom of the stream. They stay put pretty well unless people mess with them, which we've had happen. But that collects up to 5 years worth of data on a battery, and you can just go out and ask it, tell me your data, and it loads it to your phone, and you take it home. This is one of our members. This is part of the CSLAP program. We're measuring some of the water parameters and nutrients in the pond in Troy, and we send the water samples off to a lab. We're in year 1 of about year 3. Like I said, it's an environmental justice project to see if we can do something with an urban pond. This is our egg stocking. So this was just last week. We put some of these in. You can see the top of the Whitlock box there, and then we bury it with a cage full of gravel around it to protect the eggs. Don't feel so bad for George there. The water is actually warmer than the air. So he's in the warmest spot that was around that day. We put in about 3,000 eggs in 6 locations. This is the brook trout. I haven't talked much about fish, but everybody wants to get their paws on a brook trout. This is New York's native fish. They're very small. They're under a lot of pressure, but they're very resilient species. They're generally relegated now to the headwaters of streams, so you only find them now generally in very small streams, partially because of environmental reasons, but partially because they don't compete well against the brown trout, which is a naturalized species that's been naturalized all over the world. The brown trout grows faster, can tolerate warmer water, and is a much more efficient fish eater. So the poor brook trout are under a lot of pressure. But the reason they're around at all is because of their resilience. They can get over incredible fish barriers to get into places where the brook trout can't go. They also spawn at a younger age and a smaller size in places where brook trout can't do that. So they're extremely resilient fish. And like I said, a lot of our effort is finding them, getting information about them and protecting them. Like I say, everybody wants to get their paws on the brook trout. Oops, how'd that happen? Anyway, this is another interesting fish, almost done, last slide. This is called the tiger trout, and it's a very unique thing. This came from the Rensselaer Plateau, and one of the streams on the plateau. It's a hybrid between a brook trout and a brown trout. Well, that doesn't sound that funny, except that the brook trout and the brown trout are not really closely related. They're not in the same genus. So an intergenus hybrid is a pretty rare thing. As a matter of fact, a brook trout has 84 chromosomes and a brown trout has 80. Just the fact that this is possible is just a surprise of biology. It's just hard to imagine how that works, on a chromosomal level. Plus, the only way it works is if the brown trout egg is fertilized by the milk of a brook trout. It can't go the other way. And these fish don't intentionally spawn with each other because trout spawn outside, they're external spawners. It's just an accident that the gametes met in the stream. So they probably were spawning near each other. And, the fact that you get a live fish out of this is just an amazing happenstance. This fish this picture is a couple of years old. So either this fish is now enormous or he's probably lived his life and has passed away. But that's an interesting fish. That's a tiger trout from the Rensselaer Plateau.
Tom, there was a question how big the last fish was, the last brook trout in that. Yeah,
that's about a 5-inch fish.
How old is that fish?
That's a 5-inch fish, and it's probably 2 years old. So they'll be about 3-4 inches after 1 year, called young of the year, and that's probably a 2-year-old fish. That fish is big enough to spawn. Even though a brook trout can get as big as a salmon if you give them enough water, They're like I say, they're resilient and they can spawn at this size. So, you know, in our streams around here, if you catch a brook trout that's 12 or 14 inches, that's a trophy fish. But
Mhm.
you can see a brook trout, you know, upwards of 30 inches in a different environment.
And that tiger trout, how big was that one?
I didn't actually handle that fish, but judging by the some of the cues there, I'm going to say that's about a 6 or 7 inch fish.
Well,
Now these fish don't spawn. They're sterile. They're what they call mules. They're incapable of spawning. So it's a one-off.
okay.
Okay, here's your test. Do you see a very content and well-fed fisherman, or do you see a fish barrier, an eroded bank, and a floodplain? If you said all of the above, you win. Thanks, anyone. If anybody has questions, we can have a seat on the bench and I'll answer your questions there.
Thanks, Tom. That was great.
All right.
So you said that what size is a good size for around here for trout?
Yeah, so well for a brook trout, just because of the nature of the stream they're in, for instance, you know, I hate this, you know, I don't want to do what they call spot burning, which is tell people where to go fishing because you get too many people. But a
Yeah.
stream like this would be a typical brook trout habitat. So if you caught a fish, a brook trout out of here that was, you know, 12 inches or maybe even 14 inches, that would be probably the biggest fish in that stream. So that, you know, they're sort of unable to grow much larger than that just because of the resources that they're living in.
Got it.
Typically, you'll see fish that are between that 5-inch fish and a 6-inch, 8-inch fish. They'll be the most common size, but somewhere in the big pool there'll be a big one like that. That's a 3 or 4-year-old fish. That's, you know, that if it's a male, it's a, you know, a regular spawner. If it's a female, she's the one that's going to put out the most eggs. So those big fish are really important to the population just because of their ability to reproduce on a larger scale.
Thank you.
Brown trout are different. Brown trout are they get bigger faster. They generally inhabit the valley bottom streams like the Kinderhook and, you know, some other places. They're not really good at spawning when they're small. So you generally see them much larger. People routinely catch a brown trout that are, you know, 20, 22, 24 inches out of the Kinderhook. That's a big fish. Typically you'll find, you know, a brown trout in the order of, you know, 12, 14 inches regularly. And the same with some rainbow trout, which we didn't talk about much, but rainbows are another species of trout that have been naturalized in. They're not as good. They're not as common around here. First of all, because they stock them less, and second of all, because they like to spawn in much faster water, and it's just not the perfect place for them. There is some natural spawning of rainbows, but they're less of that than the brown trout.
So someone asks, when you fish locally here, is it mostly brown trout that people catch around here?
Yes. So if you were to, you know, if you were to catch a trout and didn't know what it was, and you took a guess, that's probably a brown trout. You're probably right. You know, not that you can't find rainbows, but you know, the most common variety of trout that you see would be, you know, would be the brown trout. In New York, the salmonid species, there's not that many of them. You got the brook trout, then you've got the naturalized ones, the brown trout and the rainbow trout. A native trout is the lake trout. You generally see those, like it sounds, in large bodies of water in lakes. And then we have some Atlantic salmon, some landlocked salmon up in the Great Lakes. We have some landlocked salmon in Lake Champlain, and they run up the Saranac River. And then we've got some Pacific salmon that were introduced into the Great Lakes. And when you hear about people fishing on the Salmon River, they get these huge steelhead, which are basically rainbow trout that get huge. And you know, and cohos and I'm losing it on the. There's a couple of species of Pacific salmon that are, you know, that they get big in the Great Lakes and they come up the Salmon River to spawn. It's kind of a managed fishery because you know, DEC has a hatchery on one of the tributaries to the Salmon River, and they capture the Pacific salmon, which die after they spawn. So they capture some of those fish and they artificially inseminate the eggs. They raise them to fish to a small, to a, you know, till they're, you know, they're about 1.5 inch or 2 inch fish. Then they let them go in the Salmon River, where they wind up downstream in the Great Lakes. And after a couple of years, they come back to their natal stream to spawn, where the cycle starts all over again. So if DEC wasn't putting in a whole bunch of, Pacific salmon, that fishery might slowly fade out. So, and there's some other smaller, not well-known salmonids, what they call whitefish. There's a couple of species of whitefish in the Adirondacks and in the Great Lakes that are also salmonids.
Great. We have a few questions that have come in. So Bob asks, if you had all the resources and time in the world, can you estimate how many stream sites in the county could use the kind of improvement that you showed in the Poesten Kill?
Wow, that's a hard question, Bob. I can think of a few. I could think of a couple on the HDL properties where there's some significant erosion on the Kinderhook and say what's the one out on Martha's? It's the Kinderhook Creek Preserve. There's some erosion problems out there that I'd love to see fixed. There's lots of smaller places. And there's probably some places I don't know about because there's a lot of stream that, it's private property. You just can't go there. One thing I would like to, I think if I had money and a wish list and a stream ferry, I'd like to be able to have a program where we talk to property owners to say, you know what, don't throw riprap in the stream, don't cut down the trees and plant grass because you're not helping yourself. I know folks on the Wynants Kill here that they thought, they wanted the better view. So they cut down all the trees and they piled all these rocks on the bank of the stream, thinking it looked better and it was going to be better. And really what happened is the stream tore up their property. And then because of the riprap changed the way the flow dynamics where the stream moved over about 15 feet. So now the stream is on their neighbor's property and they have a mud puddle and a pile of rocks. So it's, messing with a stream it's sometimes counterintuitive, but I'd love to have a program where where property owners would understand some of the things that goes on in a stream and why it may be best to keep them forested, to maintain a riparian zone and and sort of get that stream to a zen and keep it there.
Do you have a target for your next stream project? How can Trout Unlimited and Hudson Taconic Lands work together on these projects?
Thanks, you stole my question. I was going to ask at the end. So we don't have a specific stream stabilization project like that. Like I say, I think what's we've got in the works is a potential dam removal project, and there's a couple of culvert repairs that are on the docket on some brook trout streams to get rid of some perched culverts in conjunction with our regional TU staff and in conjunction with the Rensselaer County Rensselaer County Soil and Water Conservation District. So we've got a small crew of people that are active, and we've got very small budgets, so we depend on other people for money. And we've got a couple of projects like eyed up for the future, but the limiting factor is money. We've got a lot of dreams, I think, but until you get some money in hand, you can't really get serious because we can't get the engineer to design something if we don't have the money in hand, so to speak. So it's it's a slow process. I think from start to finish on the Poesten Kill project was about 4 years. A lot of that was planning. We did the Wagner pool first, but the plan was to do that second. So because of the way the funding fell in and fell out, we did the Wagner pool first and then the firehouse second. So it's kind of a bit of a dynamic, keep your seatbelt on kind of process.
Is that project completely done? Jeff wanted to know if there will be continued work at the firehouse.
The only thing that's left at the firehouse is some more replanting. In those pictures I showed you, we did a whole bunch of planting there, and we're applying for a grant to get some more nursery stock to do some more planting. Of course, we have to work that out with the property owner, which is the fire company. So we're sort of in that process now. Could we move up the Poesten Kill farther? You bet. I mean, from there all the way up to the 351 bridge, there's a lot of problems that are very similar. But you have to use your money wisely. And, some property owners like doing this, some property owners don't. It's best if you can get both sides of the stream. There's a lot of moving parts to these projects. Could we go up the Quack and Kill? Sure, we could. There's a lot of things we could do up there too. And these are streams that just start and finish, in Rensselaer County. The Kinderhook crosses state lines and then it crosses county lines and, enters the Hudson. Is a pretty big stream. Is there work to do on that stream? Yeah. I mean, it's limitless. I think the real secret is to pick, the places that are most severe, and start there and see, because sometimes if you fix the big problem, the smaller problems, tend to heal a bit. The stream dynamics are such that, the stream will eventually reach equilibrium on its own. It might take 150 years, or it might take 10. So it's, that's kind of a hard question too.
Thanks. How grave is the concern about the dry summers that we've had?
Yeah, that's a good one. So in the grand scheme of things, really dry summers and really wet summers, are a blip. So in terms of fish and insects, there's almost always some part of the stream that's a refuge. There's enough water and enough cool water so for those creatures to survive. Insects are a little bit harder, but fish, especially brook trout, can migrate pretty far. Sometimes they'll travel miles in the stream to find a better habitat. So does it hurt the population? Sure, it reduces it, but it's not going to eliminate it. The things that really eliminate it are barriers, and those kinds of things, and dramatic changes in the environment. Like, if someone were to, completely log out a very large area, you get a lot of erosion. Like out west, big wildfires can really cause big problems because, after the fire, all the ash chokes the stream out and it kills nearly everything in it. And if you kill the bottom of the food chain, you've killed the top of the food chain too. So it's, large scale events like that aren't that common here. The dry years, they're not helpful, but they're not the end of the world. It's part of the part of the environment. And brook trout have been here since the glaciers. There's isolated populations of brook trout that are probably there because glaciers blocked up the streams. The fish wound up in these little lakes. Then the ice went away and the fish were isolated in a small part of the stream. So they're very, very resilient fish.
We're right at time. There's so many comments. Great presentation. Thanks for all your work. This was a great talk. Let's see. Great job, Mr. Carroll. Thank you so much. Very nice presentation, Tom. Thanks for all your wonderful conservation work. Yeah, everyone's real thankful and learned a thing or two. And what a great hour. So thanks everyone for coming, and thank you, Tom.
Yeah, there's our contact information. If you want to reach out to our chapter or to me, the email addresses are there. So thank you, everyone. Thanks for your attention, and I appreciate your interest in conservation.
Perfect. Thanks so much. Have a great night, everyone.
Night, everyone.